The formation of the universe, a detailed journey from the Big Bang to today. Have you ever looked up at the night sky and wondered how it all began? How the stars, galaxies, and even the atoms in your body came to be. Today we're diving deep into one of the most profound questions humanity has ever asked. How did the universe form? This is the story of the universe, from its explosive birth to the vast cosmos we see today. The Big Bang, the beginning of everything. About 13.8 billion years ago, the universe as we know it didn't exist. There was no space, no time, no matter. Instead, there was something called a singularity, an infinitely small, dense, and hot point. And then, in a fraction of a second, everything changed. This is the Big Bang, the moment the universe began. It wasn't an explosion in space, but rather an expansion of space itself. In less than a second, the universe grew exponentially in an event called cosmic inflation. During this time, space stretched faster than the speed of light, and the universe went from the size of a pinhead to the size of a galaxy. In the first few moments after the Big Bang, the universe was unimaginably hot and dense, trillions of degrees Celsius. It was filled with a chaotic soup of fundamental particles like quarks, electrons, and photons. As the universe expanded and cooled, quarks combined to form protons and neutrons, the building blocks of atomic nuclei. About 3 minutes after the Big Bang, the temperature dropped enough for protons and neutrons to fuse into the first atomic nuclei, hydrogen and helium. This process is called nucleosynthesis. For the next 380,000 years, the universe was so hot that electrons couldn't bind to nuclei, and light couldn't travel freely. It was a glowing, opaque fog of energy. The cosmic dark ages and the first light. After 380,000 years, the universe had cooled enough for electrons to combine with nuclei, forming the first atoms, mostly hydrogen and helium. This allowed light to travel freely for the first time. The universe became transparent, and this ancient light is still visible today as the cosmic microwave background radiation, CMB. The CMB is like a baby picture of the universe, showing us what it looked like when it was just 380,000 years old. The tiny fluctuations in temperature you see here are the seeds of all the structures we see in the universe today: galaxies, stars, and planets. The first stars and galaxies, lighting up the cosmos. For millions of years, the universe was dark and filled with hydrogen and helium gas. But gravity began to pull matter together, forming dense clumps. Around 100 million years after the Big Bang, the first stars ignited. These stars were massive, hundreds of times larger than our sun, and burned brightly, lighting up the cosmos for the first time. When these early stars died in spectacular supernovae, they scattered heavier elements like carbon, oxygen, and iron into space. These elements became the building blocks for future stars, planets, and even life itself. The birth of galaxies and cosmic structures. Over billions of years, gravity continued to pull matter together, forming galaxies and galaxy clusters. Our own galaxy, the Milky Way, formed about 13.6 billion years ago. Within galaxies, clouds of gas and dust collapsed to form stars and planetary systems. About 4.6 billion years ago, in a quiet corner of the Milky Way, a cloud of gas and dust collapsed to form our sun and the planets, including Earth. And here we are today, looking up at the stars, trying to understand our origins. One of the most astonishing discoveries of the 20th century was that the universe is not static, it's expanding. Galaxies are moving away from each other, and the space between them is stretching. This discovery led to the theory of dark energy, a mysterious force driving the accelerated expansion of the universe. Today we know that the universe is made up of about 68% dark energy, 27% dark matter, and only 5% ordinary matter, the stuff we can see. Dark matter, which doesn't emit light, plays a crucial role in holding galaxies together, while dark energy is pushing the universe apart. The cosmic forces. 4 fundamental forces govern our universe, but one reigns supreme across cosmic distances. Watch as gravity, shown in blue, shapes entire galaxies, while electromagnetism's rainbow tendrils only reach so far. The strong and weak nuclear forces, glowing red and blue, remain locked inside atoms. Yet one mystery endures: Why does matter outweigh antimatter? This imbalance, possibly explained by CP violation, is why we exist at all. Our cosmic home stretches 93 billion light-years across, but this is just what we can see. Beyond this glowing sphere of the observable universe? Possibly infinity. Some theories suggest the full universe could be numbers too large to comprehend. The accelerating expansion. For 13.8 billion years the universe has been growing. But in 1998, astronomers discovered something shocking shown by these exploding stars. Instead of slowing down, the expansion is speeding up. Dark energy, making up 68% of the cosmos, is pushing galaxies apart faster every day. Space-time warps reality. Einstein revealed space and time are woven together like this cosmic fabric. Watch how planets create dimples in space-time. That's gravity. Even your GPS relies on this. Satellites high above Earth experience time slightly faster, requiring constant adjustments. The shape of everything. Cosmic background radiation maps reveal our universe is flat, like this infinite sheet. Had it been spherical or saddle-shaped, the fate of everything would be different. This flat geometry means our universe will expand forever, growing colder and darker over trillions of years. The fine-tuning mystery. Adjust any fundamental constant just 1%, and stars, planets, or life itself become impossible. This incredible fine-tuning has scientists debating. Is this cosmic luck? Evidence for parallel universes? Or something beyond our current understanding? What does the future hold for the universe? Scientists believe that the expansion will continue, driven by dark energy. In trillions of years, galaxies will be so far apart that the night sky will appear empty. Stars will burn out, and the universe will grow cold and dark, a fate known as the heat death. But this is just one possibility. The universe is full of mysteries and there's still so much we don't understand. Every discovery brings new questions, and every question brings us closer to understanding our place in the cosmos. The universe is a story that began 13.8 billion years ago with a single, extraordinary moment. From the Big Bang to the formation of stars, galaxies, and planets, every step in this journey has shaped the cosmos we see today. And as we continue to explore, we uncover not just the secrets of the universe, but also the story of ourselves. Thanks for joining us on this incredible journey through time and space. If you enjoyed this video, don't forget to like, share, and subscribe for more cosmic adventures. Until next time, keep exploring,